Good afternoon also on my behalf and welcome to the Let's Talk Electrification, how to select pump breakout session. It is very natural for us when we are on the verge of something new that we put our focus on the unknown, interesting stuff, and electrification is no exception. We look into the batteries, electric motors and inverters, and we very easily put aside all the conventional stuff we think we know. Instead, when you start your electric journey, you should start to look into the whole system and think about the component selection criteria, including pumps. My name is Ari Puranen. I am the Application Engineering Manager at the Parker Hannifin sales company Nordec. The purpose of this session is to look into the system requirements, what it takes to make a most efficient system, and the pump plays a key role there. We look at the inputs that are coming outside from the system towards the pump, as well as consider when we actually go to the actual component, what are the characteristics and the things that will impact from the pump towards the systems. We are not going to go into details about technical data or any calculations or such, because we just don't have enough time for that. When we look at today's machinery, we all know that the total efficiency is not very good. There are various reasons which are causing this, but when you start to talk about electrifying your machines, the energy efficiency becomes the major topic. You have to re-evaluate the system requirements, including the pump technology, and you have to be very sure that what are the trade-offs of your choices. So, it all starts from the work cycle. You have to be available, or you have to be aware of your baseline work cycle data. You define the time of operation, the time of the standby, and then also what are the possibilities to charge the machine. Because when you go to the fully electric machines, you have only a limited amount of energy available. Charging of that energy storage, it's not that easy as it is with the diesel engine. So you are limited with the power available. So then when you talk about the power demands, with the conventional diesel engine machines, you usually measure or you dimension your components towards the peak power. When you have the electric motor, you are actually following the average power. And there you are going to measure what are the continually power that you use, what are the high power demands, and what are the low power demands. And then you can actually see that how much you can overtorque the motors. And by doing that, you can downsize the electric motor. So choosing the right type of the pump and the right size of the pump will have a big impact on the electric motor choosing, which will impact the whole system as well as the cost structure. So when the energy study is done, it is time to think about what other things are impacting your pump choice from the system towards the pump. How can you fulfill those requirements? And also, what kind of choices what you make will impact towards the system, because different pumps have different characteristics. This also determines how much you are able to optimize the system and how much you need to compromise. So when we look at the inputs that will impact on your pump choices, so duty cycle is one thing for sure. The intermittence of the work cycle. How much is the actual pump operation time versus the machine time? Is the pump idling all the time, or can you stop the rotation? Has the machine possibility to cool down? Is it possible to charge the machine, and so forth? System circuitry. What kind of system you are driving? Are you able to change the system? How much you need to change it? Are you running on the open center? Are you running on the LS? Or is it a combination of that? Or can you use an electric LS? What is the efficiency you need to increase? The baseline and the energy studies will tell you that, hey, These are the things I need to do in order to have the productive machine, and I don't have to invest too much on the batteries. Noise, it becomes more important, because when the diesel engine is gone, your pump is the biggest sound emitter in the system. The mechanical sounds, the system sounds, they will be emphasized during the operation time and can have a big impact on the driver's work experience. And finally, the price. All those things that you do with the system optimization and such will have a trade-off that it will most likely increase your cost. Are you able to sell the machine, and what is the possibility for the machine owners to earn? So it's a balance of effective machine and also on the product cost. So when you actually have come to the conclusion that there are certain types of pumps you want to use, then you come to these kind of physical and technological specifications. When you work towards from the system towards the pump, and then you come to the place that you are actually choosing your electric motor, you can find out that the sizes and the envelopes or flanges don't match. So it is possible that you actually have to do a certain iterations. Very seldom you actually can get it right on the first time. Then you can also find out that the permitted ratings of the pump are not suitable at the end of the day. You cannot operate the pump with the low enough speed, or you can't reach the high enough RPMs with the selected pump. Also, there is a performance differences when you are going back and forth on the pump operation speed ranges. Price and availability. Some pumps are easily to access and they have a low cost. Some pumps are more expensive and can have a longer lead times. Is it fixed or variable? It's a key question. Depends on how you want to build your system, how much you want to do with the hydraulics and how much you want to do with the software. With the fixed pump, usually you can simplify the hydraulics significantly, but the trade-off is that you have to have the engineering capability to do the softwares, and most likely it will also require more testing. This will also mean that you have to redesign the whole system from the beginning. What kind of controls you can use? Do you want to use a hydromechanical controls, software controls? Are you driving things directly from the pump controls, or are you driving it from the inverters to the electric motors? And then we have lots of other different characteristics, lifetime, serviceability, and so forth. In some cases, it may be feasible to choose a specified pump for the electric motor use, which has the optimized speed range, has the optimized noise level, and service-free axles. So when we start to look at the pump motor package, we can categorize them in two categories. We have the electrohydraulic actuator and we have an electrohydraulic pump. They both have pros and cons. If your system has the capability to deliver energy back to the battery so that you can do energy recovery and it's worth of doing, then your choice will be electrohydrostatic actuator. It will increase the efficiency of the system significantly, but it also means that your control system is more complex and you are entering a new territories, which many often is a very interesting thing to do. But then you can also use this system the same way as you have it with the EHP. So it can be a flow control, one directional system where you can do load sensing or electric load sensing. With the EHP, we usually mean that you have only energy flow to one direction. You are delivering energy from the motor to the pump and from the pump to the system. With this system, if you use a variable displacement pump, you have certain things you need to consider. If your energy study is showing that you have most situations such that you are going on the low flow, high pressure system, it means that your pump is asking for low torque, and that enables a small electric motor. The trade-off is that you have to also make sure that you can stop the pump control, otherwise you need to rotate it all the time. If you are not able to rotate, if you are not able to stop the rotation of the variable displacement pump, it means that you are generating energy losses with the delta P. With the fixed pump, if you do an electric LS in a similar situation, you have the possibility to do a variable delta P systems, which is more energy efficient. Also, other things to consider when using a variable displacement pump is that when you stop the pump, it goes to full stroke because of the mechanical spring pushing the Schwarz blade to the far end. And when you start the pump again, there is a short delay before it downstrokes, which means that if you have a system that has a high pressure behind an actuator, you will demand a high torque from the motor. And in some cases, that is the reason that you have to increase the motor size. Similar thing can also happen in the cold conditions when the oil viscosity is very thick and it generates even more delay. So if those kind of things have not been considered during the design phase or test phase, that can actually stall the electric motor. So as a summary, it all starts from the work cycle. That is the key thing, whatever you do. You need to work from the system towards the pump and from there to the electric motor. Otherwise, it is impossible to do an optimized and efficient system. You need to decide what is the most important key characteristics to you. Where do you want to focus? Is it the efficiency? Is it the noise? Is it the cost? Or is it just that you don't want to change that much of the system side so that you have to maybe do an easier approach to the system itself? And then it's also like that how much you want to do with the hydraulics and how much you do with the software. There are possibilities what you can do, there are certain trade-offs, but it all drills down to the ability to do the actual design. Are you going to do it in-house or do you want to use a partner? And then, can you also maintain those choices out in the field? Whatever you choose and wherever you are in your journey, Parker team is more than happy to help you. And you just only have to reach out to us and we will be there for you. From my side, I just want to thank you for listening and I hope that you can enjoy the rest of the event.
Thank you so much, Ari. I have actually a follow-up question for you. So how has Parker reacted on the pump development needs due to electrification?
Well, we have now lately focused on three different things. So the first is the noise. So we are now in the verge of launching a new pump series which are focusing on noise optimization. The other topic is the speed. So the conventional piston pumps, for instance, the speed range doesn't go as high as the electric motors can do. So therefore, we have developed a new pumps that has a better self-priming speed, and there is more to come. Thirdly, it's the maintenance, because it is relatively easy to detach the pump from the diesel PTOs or such, but when you have the electric motor, it can be so that it's not that easily accessible. So we have actually patented a maintenance-free axle solutions, which will increase the lifetime of the key part of the pump, which is axle, and then also lower the daily maintenance cost. And there is more to come, so we have not stopped it yet.
So your advice is to look out for the new product launches that is coming up?
Or contact us and ask directly what
Yeah.
have you developed.
Of course.